Hello and welcome to the GTU video lecture series. Myself Satyam Chauhan, working as a Atmiya Institute of Technology and Science. Today we have another session on basic engineering drawing. Today we are going to discuss planning, layout, scaling of the drawing. Mainly we are going to cover engineering drawing introduction, use of standard, layout and sheet orientation, scale, line types, line conventions, lettering standards, dimensions and dimension rules in a brief. Before starts, let's talk about the engineering drawing. The term engineering drawing, what is it? Why it is required? Engineering drawing is a powerful means of communication among the engineers. Basically, engineering drawing is used among the engineers to convey their ideas. Well, starting from the designer or the innovators who have the ideas of the engineering application, the drawing forms their ideas as a form of graphics. Engineering drawing can be used as a production. So engineering drawing is very important in terms of engineering application and its outcome. So engineering drawing hence is wisely can be produced and can be termed as a universal language. Engineering drawing, a graphic language. It's called a graphic language because the word, why we need the graphic language? Because our language as a word language is inadequate for description of size, shapes and features completely and concisely. By definition, engineering drawing is a type of technical drawing to convey fully and clearly the requirements of the engineered or designed items. It's usually created in accordance with the standard conventions, layout, nomenclatures, interpretation, appearance, size, etc. Here comes the standard. Later we will discuss what is standard and how it is used. The purpose is to carry out accurately and unambiguously capture of the all geometric features, a product of a component, and finally the end goal of the engineering drawing is to convey all the required information that will allow the manufacturer to produce that component. Basically, the composition of the graphic language in engineering application, lines we are used as a surface, edge or contour of the objects. Hence this language is called drawing or drafting, can be carried out in three ways. Freehand by means is sketch. Normally we can say is sketch, or sketch means we don't need instruments. We can use by our hands only. Secondly, we can use the instrument to carry out the drawings. For example, rounders, protectors, scales and mini drafter, etc. And the third and most popular way these days is computer methods. For example, software like AutoCAD, ideas, etc. So by means of software we can also produce the drawings, engineering drawings. Today we are going to discuss how the fundamental and basic concepts of the engineering drawing that is very fundamental and important to know. Now it's about the drawing standards. What are the drawing standards? Standards are sets of rules that govern how technically drawings are presented. Standards is a set of fixed rules that we have to obey in order to carry out drawings. Drawing standards are used to convey the same meaning to everyone who reads them. Again, the drawing can be used internationally, more than one country engineers. So it should convey the same meaning. It should be interpreted in the same way. For example, in India, we use BIS IS 696 1972 standard. That is the code of practice for general engineering drawings. Standard drawings. And there is another term called code. What is code? Code is a practice, a certain rules or regulations, certain parameters that can be set by us expertise from the different nations and different countries. The code can be different in different countries, and there are set parameters and set guidelines that can be used as a code. So what are the standards code? Let's see. In India is BIS, that is Bureau of Indian Standards. In Australia, AS. In UK, BS British Standard. In Germany, DIN, DIN. In Japan, that is JIS. And in internationally, it is International Standards Organization, ISO. Now let's move on further on the standard of drawing layout and sheet orientation. So what is drawing layout? This is on the screen right now. We have the standard sheet. The drawing should standard look like this. It has it contains title block, it contains the symbol, a bill of material, the additional information, revisions, and a trimmed drawing space. Basically, the title block is drawn on the right hand side corner in the bottom. Normally, the dimension of title block is 185 by 65 recommended. Title block contains certain information such as whether it is drawn in first angle or third angle, what is the drawing title, what is the component name, what is the drawn or checked initials, what is the scale. The scale we are going to discuss in a later. What is the bill of material, what is the part name. The part name and bill of material table can be created on the title block. Moving further, drawing layout. Here on the screen you can see that drawing standard sheets are given by the JIS standard. It varies from A0, A1, A2, A3, A4, and in some cases A5 as well. But normally in practice we use A0 to A4. It's given by JIS in mm as we can see on the screen. The trimmed paper size is A0 to A4. So A4 size of paper is 210 mm to 297 that we are using home as a printing paper. You can see A3 is just double the size of A4. Again A3, A2 is double the size of A3, and so on. A0 is double the size of A1. A0 is the largest drawing sheet normally practiced, we used in industry. A0 size, the length is almost 1.1 meter, and this is again trimmed paper size A0 to A1. Sometimes margins are kept. In the later slide we will see what are the margin kept and why it's kept. Orientation of the drawing sheet. Say type X, A0 to A4. On the screen you can see the normal standard of the drawing sheet. This line is called border line, border of the drawing sheet. Title block, drawing space, and for A4 size it can be drawn vertically. As you can see on the right hand side, the title block is smaller than the normal one. That size is only for A4. So apart from the margin on the left hand side, there's dimension C, as you can see on the other three side, and the D. So what are the dimensions for them? It differs for the different sheets. For example, for A4 to A3 and A2, the C is kept 10 mm and left hand side margin is kept 25 for all sizes. For C, for A0 is kept 20 mm. Let's move on further on the drawing scale. What is drawing scale? Drawing scale is the ratio of linear dimension length, for example length and size, of an object to the actual size, to the real size. So that is the ratio of the drawing, like the object drawn on the drawing, and the size to the actual size, for example true size. So the size in drawing to the actual size. For example, the size on the drawing, we can see the object is reduced, and by the red line, for example on the drawing is 10 mm but actual size length is 20 mm. So what we are going to write is 10 as to 20, or say 1 has to 2. So the scale is 1 has to 2, and this type of scale is called reduced scale. The designation of scale consists of the word scale followed by the indication of its ratio as follows. Scale 1 has to 1 for full scale. Scale x has to 1, and if x is greater than 1, for example 2 has to 1, 10 has to 1, 5 has to 1, that is called enlargement scale. That means the drawing on the drawing size of the object is larger than the actual size of the object. And on the contrary, if the drawing is smaller, for example scale 1 gem x, and x is greater than 1, for example 1 has to 2, or 1 has to 2.5, 1 has to 5, 1 has to 10, this type of scale is called reduced scale. So the dimension shown on the drawing, here it is very important to understand these terms, the dimensions. Students always make mistakes when they use the term scale and the dimension. They tend to think that the dimension also needs to reduce on the drawing. It is not like that. The dimensions are always marked as a true dimension. For example, see here is a pencil of full scale size. So if we keep half the scale, if we draw by reduced 50%, the scale dimension will remain the same. However, the actual size of pencil will be the smaller. Scale is always selected by the required space or the required layout. If we have limited space, we are not going to use the larger drawing. So we can see here, if the pencil scale is reduced further, for example quarter size, even though the dimension remains same. So scaling versus dimensioning, it is important to remember that drawing can be different scales, but the dimensions are always at full scale. Now moving further, we have lines. In engineering drawing, line is the basic element, and we need to understand the basic difference between them. There are certain lines are used in the engineering drawings, and we need to remember at what application which line should be selected. Let's move further. We have the types of line. The continuous thick line is named as a visible line. Visible line is dark and it's drawn 1.2 mm dark to 0.8 mm dark thickness. Second, moving on, the basic four types of line. The second one is continuous thin line, and that is the most important line we need to remember, because continuous thin line has the most number of application in general drawings. It is called dimension line, extension line, and projection line, hatching line, ladder line. These all lines are drawn as a continuous thin line. Dashed thick line. Dashed thick line is hidden line. For a current view, if some feature is hidden, then it is to be drawn by dashed line or say hidden line. Chain line. Another important line is chain line. Mostly we used as a center line. So what are these meanings line? Visible line, what does it says by visible line? Visible line represents features that can be seen in the current view. What are the edges, what are the surfaces, what are the contours, or what are the radius, chamfers, fillets can be drawn by visible line. Means continuous thin line. What are the hidden line? Again, it represents features that cannot be seen in the current view. It is important to remember that the current hidden line must be visible line in other view. We will see this feature